Okay. Well, so first of all, very briefly, and some details on our company, Aguas de Alicante, and its context of the region of Alicante. Alicante is a Mediterranean coastal city in the southeast of Spain. Uh, the population we served is roughly 500,000 inhabitants, but it gets to be more than 700,000 in the summer. Um, the Alicante is located in one of the driest areas of Spain. It's a semi-arid climate, and for this reason, it's subject to extreme weather events. It has long drought periods, but it also has torrential rains and fast flood periods. Even though the annual rainfall is less than 300 millimeters per year, we can get to have 200 millimeters of rain in just one day. So just two-thirds of the annual rainfall in one day. Alicante has also a context in which the coastal water are a sensitive environment of economic relevance for tourism, with the valuable sea and coast ecosystems and some protected areas. And as for the company, we manage the complete urban water cycle in the city of Alicante and the surrounding municipalities. That is to say, the drinking water production and supply, wastewater collection and treatment, and also um, the reused water treatment and supply. The length of the water distribution network is roughly 2,000 kilometers. There's also a transport network of 170 kilometers of track mains, which deliver 40 million cubic meters of water to the cities. And there's also a sewer network of more or less 200 kilometers of mains, including stormwater channels with large sections up to 10 per 5 meters, and for example, an underground combined sewer overflow retention tank of 60,000 cubic meters. But in the B-WaterSmart project, we have focused all of our efforts of our pilots in the wastewater treatment plants. So Alicante has two wastewater treatment plants. The Monte Orgegia plant in the south of the city with a capacity of 60, a theoretical capacity of 60,000 cubic meters per day, with an equivalent population of 200,000 inhabitants. Um, it has a combined, it has a conventional aerated biological treatment, um, plus tertiary treatment for water reuse and disinfection system. And in the sludge line, it has anaerobic digestion and cogeneration. It has a production of 0.8 mega cubic meters per year, and it produces 11 hectometers cubic of water per year of reclaimed water. And then in the north of the city, we have the Rincon or the Leon wastewater treatment plant. It's the largest plant. It has a capacity of treatment capacity of 75,000 cubic meters per day. The served population is more than 300,000 equivalent inhabitants. In the water line is very similar to that of Monte Orgegia, but it also has a desalination stage in order to reduce the conductivity of reclaimed water. The sludge line is also composed of anaerobic digestion and cogeneration. Currently, the biogas production is roughly 1.5 mega cubic meters per year. And the reclaimed water in the last year was 17 hectometers, cubic hectometers per year. As it has this desalination plant, it's also currently producing almost 500,000 of cubic meters of brine per year. Especially in the case of the wastewater treatment plant of Rincón de León, we have the goals of increasing both the biogas production and the reclaimed water production in the next years. So, in the context of the B-WaterSmart project, um, the Living Lab of Alicante focused on some specific goals within the project. First one was that of innovative treatments for the promotion of water reuse for more efficient and safe operation. The second one was the decarbonization and the production of green energy. And the third one was that of getting added value by producing added value products in the wastewater plant. That is what we, in brief, what we call uh, the transition from wastewater treatment plants to biofactories, from um, waste treatment to to value and resource production. Um, we will come back to these objectives later on. But first, I would like to say in what has already been done in this path to the biofactory or ecofactory in Alicante. Well, first of all, water use is key for us. It started as early as 1996, and currently, as I mentioned earlier, in Monte Orgegia, we are reducing more than 6 cubic hectometers per year. And in the case of the Rincón de León wastewater treatment plant, sorry, I think that this is, I don't know if this figure is correct, but a similar amount of reused water. As for the case of urban water reuse, the master plan for reused water in Alicante was approved in 2003 and is currently being used for irrigation of green areas, street cleaning, and also for the cleaning of the wastewater network. Additionally, private users have had access to reused water since 2004 for garden irrigation and golf courses. Currently, actually, 80% of the city's green areas are irrigated with reused water. And in the last decade, this area of green, the surface of green areas in the city has tripled. Also, currently in place in Alicante, biogas production in both wastewater treatment plants. In the case of Monte Orgegia, we are producing 0.8 mega cubic meters per year, which allow us to produce 1.5 gigabytes hour per year. That means that we currently have a self-sufficiency or self-consumption of 35% in terms of energy. And as for the Rincón de León wastewater treatment plant, we are currently producing 1.5, more or less, mega cubic meters per year, which allow us to produce more than 2 gigawatts hour per year. The result is currently a self-sufficiency rate of 25%, which will be increased in the next years. Finally, I would like to mention the energy recovery from sewage sludge, and this is especially important for today's presentations. Um, in this case, in brief, we are drying the wastewater sludge by making use of the waste heat produced by a nearby cement plant managed by Cemex. Then when the sludge is dried, we are using the dried sludge as fuel for the cement plant and also for agriculture use. Finally, the resulting acids are used as a concrete component in the plant. This process allows us to save the equivalent to more than 9,000 tons of fuel and avoid the emission of 20,000 tons of CO2 to the atmosphere. With a bit more of detail, as I've said, this will be important for some of the next presentations. Um, you see that the process, this relationship between the cement production plant and the wastewater treatment plant of Rincon de Leon starts when the sludge is dried after the centrifuges. Then this partially dried sludge is sent to Cemex, that is very close to the wastewater treatment plant. At Cemex, the sludge is dried using the waste heat of the kiln in the plant. And then the dried sludge is used as fuel for Cemex. But something important is that we also get a large amount of reject water. So as I've said, this is something we will come back later. So coming back to this slide I already showed, I will show you sorry, there should be some, okay, yeah. These are the technologies that have been tested in Alicante within the World Package 2, that is to say that the package in B-WaterSmart related to technology development. The first one was devoted to the valorization of oils, fats, and food waste to produce biogas. The second technology was related to energy recovery from the wastewater outlet with macro turbines. Then we had a pilot on brine valorization for water reuse and the production of byproducts. And finally, we had the pilot on nutrient recovery. So the relationship of these pilots with the objectives selected in the living lab of Alicante is the one you can see now in this slide. So as brine valorization was aimed at promoting water reuse and also a more efficient operation. There were two pilots oriented to decarbonization and the production of green energy, that of microturbines, and the one on the valorization of food waste to produce biogas. And finally, the one that we will be presenting later on, the nutrient recovery pilot, which was obviously related to the objective of getting high added value products. So this is what you see right now, and I'm about to finish. Is the current the flow, the process flow in the wastewater treatment plant of Rincón de León um, prior to the project. So there were two um, treatment lines, one a bit older than the other, and in one of them we also have a process for water reuse in which we had a line with sand filtration, conventional tertiary treatment of sand filtration and ultraviolet disinfection, and on the other hand part of the flow was treated with ultrafiltration and reverse osmosis. Both flows were then mixed to get the right water quality for water reuse. As for the sludge line, we had a thickening process, then the anaerobic digestion, and the mechanical and then low temperature drying process for the watering. But in the B-WaterSmart project, we have added the new processes you see now in light green in this slide. So after thickening of sludge, we added the co-digestion pilot. In the reverse osmosis process, we added a composed process of electrodialysis and electrochlorination to produce sodium hypochlorite. At the outlet, actually not in the outlet of Rincon de Leon, but in the outlet of Monte Orgegia, we inserted this microturbine to produce electricity, and the one we will be discussing today, the CEBAP technology for the valorization of ammonia. So this is I think this is the last slide for me. Yep. And with this, I have finished my introduction of the Biofactory concept that has been developed within the B-WaterSmart project in Alicante.